Okay, this is assignment number 2 again. But this time we're looking at question number 8. Somebody asked for number 8. So let's look at it. It's basically a picture. You've got a sled with two girls pushing and pulling on it. One is pulling there this way, and that's 80 newtons of force. And I'll just put the angle in here, 30 degrees. Right? Now you've got another girl on the other side who's pushing. So her force goes down like this. Oops, let me just try that again. I got some moisture on my screen here that's messing me up. Hang on, we'll get it. I gotta dry the screen off first, I guess. There we go. Finally, there it is, 60 newtons. And there's an angle that goes with that one too. And that's 40 degrees. The mass of the sled is 20 kilograms. So we'll put that in the middle. Okay. And there's a mu also thrown in there. I'll just write it up on top here of 0.3. Before we can go any further, we have to finish this picture. And there's a lot of work to do to finish this picture because it doesn't show the normal force, which we have to put in here, or the gravity force, which we have to add in here. And then because there's a mu, we know there's friction. If you look at the way these girls are pushing, the box or the sled, whatever it is, toboggan, has to go to the right. So the friction force is over here also going this way. So see this complicated picture. All right. Now the first thing we have to do is we have to resolve these angled forces into their vertical and horizontal components, right? We have to resolve them. So I'm going to do that on a separate picture because it's this small little iPad, it's a little bit crazy. So let me just redraw just the two forces on either side with the 30-degree angle here and the 40-degree angle here. And of course this was 80 newtons and this one was 60 newtons. Okay, let's resolve them into their vertical and horizontal components. In red, I'll do the horizontal components. So this way, right? And then the other one has a vertical component upward like this. Now to get the components, you have to start here at the beginning of the black arrow. You don't start at the tip of the arrow, you start at the start, right? The tip of the arrow is where the arrow finishes. So we went to the right and up. Now let's look at the other one. In the other one, we have to kind of go at the tip of the arrow down first and then over this way to get our components. And you have to draw arrows, not just lines, because you have to know which way these are pointing. You'll notice that the first girl on the right, on the right, the 80 Newton girl, she's pulling kind of upwards, so she has an upward component to her pull. But the girl in the back who's pushing in a downward way has a downward component. So they're kind of working against each other, aren't they? But you'll also see that the two red lines, they're each pushing to the right, and that's why the toboggan's going to end up going to the right. Now to figure these out, we need to do some trigonometry, right? So this side will be 80 cos 30, and this one will be 60 cos 30. So if we figure those out on your calculator, make sure your calculator is in degree mode before you go doing trig. 80 times 30 cos is going to give us about 69. I'm just going to round them off. And then we have 60 times the cos of 30 on the other side, which is about 52. Okay, those are the horizontal components. The other sides are 80 sine 30. I know that sine 30 is a half. Forgot the 80 there. 80 sine 30. So sine 30 is a half, so that's going to be 40 for that uppy downy guy. And then the 60 times the sine of 40 is going to be about 38. So this is 60 sine 40, which is about 39 if you round it off. Okay, so in the circles, I have the components. All right. Now if I go back to my other picture, I also have a normal force here and a gravity force here. So I have a lot of uppy-downy forces, don't I? All the blue arrows are uppy-downy forces. And the only other force I have is friction, which because of the diagram, I'm just going to sort of put it down here. I don't have it room to put it up there. So I have 3 lefty-righty X arrows, and I have 4 uppy-downy blue arrows. Okay, guess what we do? F net X, F net Y. I'll do the Y's first in blue. And here's what I have. I have the normal force, the gravity force, and if you look back, I've got a 39 down and a 40 up. Now you notice how they are almost the same, which means they're not really going to do much, are they? They're going to cancel themselves almost out completely. But the 39 down is a minus because it's down, and the 40 is a plus because it's up. All right. Now, F net equals MA. And remember, we're talking about the uppy-downy A, which we expect to be 0, remember? The normal force, not sure yet. Gravity, mg, and this is going to work out to +1, which almost isn't going to matter. Okay, the mass was 20 kilograms. Go back to the first picture, we see that mass, 20 kilograms. So 20A, but A we expect to be 0. Why? Because we're talking about the up and down A. We don't expect this sled to shoot upwards or downwards. Okay, Fn is going to pop out. Now I'm going to put a minus because gravity's down. The mass is 20 and 9.8 for gravity, mg. And my +1 is still hanging around. And so I get 0 equals Fn. 20 times 9.8 is 196 down, right? And so if it's 196 down, then we should get +1 would be 195 down. All right, so that works out to minus 195, which means when I move it to the other side, I now have the normal force. Excellent. Then I do F net X, which I'll change to the other color. F net X had the force of friction, but then if I go back, I can see that it had the 52 and the 69, both to the right, so both positive, 52 and 69. All right, MA. This time it's the sideways A. Friction, mu Fn. And then we can just add the 52 and the 69 to get, what's that, 121, I think, right? Okay, mass, 20. AX, it's going to pop out. That's what we're hoping for. Now, friction. The mu was given way back here in the first picture, 0.3. And notice that the friction we decided was going to the left. So minus 0.3. What's my Fn? Right here, 195 from before. And you can now see that the A is going to pop out. So if we do the 0.3 times the 195, we've got 58.8, sorry, 0.5 minus plus 121, and the 20A is still on this side. So that means I take 121 and I subtract 58.5, and I get 62.5. And then I divide both sides by 20, right? 62.5 divided by 20 should be about, let me do it on the calculator just to be safe. About 3.125. 3.1 meters per second squared. We've arrived at the answer. Again, we did the same thing as we did in all the other questions. We started with a free body diagram, and we showed all the forces. Then we resolved our forces that were on angles. That's a new trick we learned. Then we wrote our F net y, got the normal force, our F net x, and out popped the answer. And it doesn't matter what the question had asked, it would have popped